Today is
Oh, did we lose him?
Yeah, I think.
Okay.
Computers are so hard. Oh, there he is.
Okay.
I was kicked off.
Yeah, you are. Okay,
Sorry.
can you repeat?
I was kicked off for some unknown reason. Sorry about that, folks. Anyway, pretty happy holidays. Today it's being recorded, right? Cool.
Yes.
Today is
That's how
December
we
14th, Wednesday, 2022, and this is probably the last working group meeting for this year. Today we have only one agenda item listed over there, Ivan and Prasad talking about CPT updates. So follow-up from the last session, and then we'll open the conversation to the entire team. Ivan and Prasad, feel free to take over.
Yeah, thanks, Xiangqian. So Prasad, I'm just gonna give like 2 quick updates, and then after that, like you can share whatever you have on your plate. So yeah, hi everybody. So yeah, since the last working group, I've been trying to like just spend some time doing a prototype on the CBT cap using the volume populator mechanism. I haven't had a chance to finish it yet, but I just want to quickly share the status today. Let me just switch over to my screen here. So you should be able to see my Google slide. Yes, I'm just writing like the code and try out a few things. I think like get to a point where like the API call can be very simple. The idea here is again continue to open to feedback and discussion. The idea here is like the backup software in order to like initiate like the CBT request, they just essentially just create the volume snapshot delta CR, or define a CRD, because in this approach we don't need an aggregated API server. And then they will also like the backup software will also manage like a PVC. In the last meeting, we talked about letting the populator handle all this PVC and this management. I think as I code it up and try a few things, I think it's easier and simpler if the backup software have full control over the lifecycle of the volume and the disk, where eventually like where all the CBT entries will be returned to. The general idea is still like backup software says I want a delta between 2 snapshots, and by the way, I'm gonna provision or pre-provision one volume or this a pool of volumes, and some of them would be like have the data source reference point to the volume snapshot delta CR that it created, and then the CBT populator within it. There is a controller that watches for the creation of the PVC, and it identify that hey, this is the data source reference that I know how to deal with, because the CRD has been registered with me, and then it will go off and do its like CBT like computation and stuff like that. I know like so one of the I'll come back to address like at least discuss like the concerns we had last time about like latencies and extra resource overhead in a few minutes. So yeah, so the CBT populator, volume populator within the CSI driver on the left hand side, issue a RPC call to the CSI plugin, get back all the CBT payload, spin up a ephemeral part, mount that volume that was pre-provisioned by the backup software, and then you just write all the in-memory like CBT entries to the volume. So now like the backup software would just decide when it wants to spin up like a data mover part or whatever other part to fetch those CBT entries. So that's kind of like the general direction of the prototype that I'm trying and playing around with.
Is question, so the step 1, 2, those are basically the gRPC interfaces?
Yeah, gRPC call.
Okay.
Yeah, so nothing changes. In fact, the gRPC level. So instead of, so right here, the payload come back in JSON format or whatever format, instead of like pushing it out into the Kubernetes in-cluster network, we just like write it into that volume that was previously provisioned and managed by the backup software. So that's kind of like the general direction of the prototype. Like I haven't had a chance to like really go into more benchmarking effort to see like how long it takes to provision PVs and a volume. But based on my like very like preliminary testing, like say with like in our internal lab, like with FCD, like we got like I could get like a volume of like 10 gig, 10 like 2-3 seconds. Of course, that's just all like sub cluster dependent and environment dependent, right? So it could be fast for us, it might be slow for other people. But so far, like at least in my like preliminary testing, like there hasn't been too much of an overhead in provisioning like volumes up to like 10 gig. I would just imagine like it's a reasonable size for like a CBT metadata. It'd be interesting to see how like if that continue to scale, if we change like the size of the volume. I guess one of the things that I like about letting the backup software decide to pre-provision or provision the PVC is like it can choose the size, the speed, of however it wants, like the volumes. You can pre-provision a pool of it if you want, etc., etc. The assumption that I make there is just like backup software is generally good at provisioning volumes. Um, I guess if that is not a universal assumption, is there backup software out there that's not good at provisioning volumes, then maybe that might be a limitation in this prototype here. So that's kind of like the general idea.
2 to 3 seconds is really slow. That's not fast. That's a big hit on these APIs.
Mm-hmm.
Yeah, we may be calling this hundreds or thousands of times for backup.
Yeah, like again, yes. Mm-hmm. Yeah, I think like in like at least like again, right, like on our side, like I can't speak for like other providers. But on our side, like like from talking to like Tom Bolton, like we could do it like like 50 to hundreds in a second in parallel. That's just us, right? So I can't speak for like other providers. The 1 to 2 seconds is just my like own like lab environment, just my own hello world cluster.
Yeah, I mean,
Right.
there's a certain amount of overhead with even just reading and writing resources to the API server. So like just creating a PVC takes like a second just to write the thing.
Mm-hmm. Oh yeah, good point. Like nothing is free, right? Like with aggregated SPI server, there's stuff there too that needs to there will be some sort of overhead in some way or the other. I think like it's a matter of like like stability over the network, or stability like of writing like large amount of data into volumes.
Well, no, I mean, I think we should really just set, well, I'm just trying to set the stage for things like fast versus slow. Things that take seconds to execute are not fast.
Mm-hmm. So yeah, I mean, like again, this is one of those things that we'll be interested to see what how other folks feel about it.
This is the model that is pretty close to the volume populator, right, Yuan?
It is the volume populator essentially. So the trade again, right? Like I know Xiangqian, you haven't been around. I think the main like pushback we have from the architecture is like the amount of volume that we push through the Kubernetes in cluster network going through the control plane. So by writing it to this, like then we eliminate the problem around like overburdening the API server or Kubernetes cluster entirely. You can argue that there will still be networking, but that happens between the provider and the CS, well, like the kubelet, right? Essentially, when the data is first fetched, but at least like it doesn't go into like the Kubernetes network or over the network. So that's one way to, I guess like that's the objective like I have in mind when I came up with this volume populator approach. Alternatively, we still have that like we still if we want to go back to trying. So hang on a sec. So what do you think, Xiangqian? I know you haven't had a chance to.
Yeah, it's okay. I have a couple questions for you, please.
Sure.
So if you go to slides 3,
Mm-hmm.
the backup software during the restoration time, during the populating time, it creates a PVC, right?
The PVC was
This is for backup, at least. The diagram is for backup, not for restore. This
Okay,
is
then-
retrieving the change blocks.
yeah. So the PVC was created by the backup software.
Sure. And this PVC is created for storing the change block. Sorry.
Yeah, the CBT payloads essentially. So we're not talking about backup. Yeah, we're just talking about the pre-backup phase. Where I want to do a backup, but I want to only find out what has changed between two snapshots. Whether
It
it
is
is
just metadata, right? Not
Part
the
of backup. It is part of the backup, right? So for backup, you basically take 2 snapshots, and then after that you trigger this populator to get the change blocks.
But the data, what does the data source reference mean?
it's just the PVC API to initiate like the volume populator, right? So like inside the I'm still learning about the volume populator as well, like so in a couple of weeks. But the idea is like the volume populator will watch the PVC resources, and
Yep.
then like there is the resource reference is the I guess the entry point, if you will, into the volume populator execution. Previously, like to do restore, we only do data source, right? Whether it is volume snapshot, and then we are only limited to volume snapshot or another PVC. So the resource reference is just the entry point into the volume populator.
Yeah, that field is there to serve the purpose during the volume population, during the volume restoration process. And it sounds like we're reusing this field to treat it as the source of the change block track content, right?
Yeah, essentially, right? Like it's not so maybe like yeah, essentially it's up to the volume populator to decide how that quote like unquote like a resource restore works, right? It's just I tend to think of volume populator not so much about restoration, but more about like pre-populating the volume with data so that the volume is not empty. So whether it's restorations or just like traditionally init contain type of approach to pre-populate data. At least that's how I think of it. I don't think of it as a restore operation. It's more like a populator and population type of operation.
It might be concerning to the API reviewers if we won't take this approach, because the data source ref over here, it sounds like the popular what the popular would be doing is actually create a volume that is from the volume snapshot delta collected from 2 snapshots. It's basically a restoration process instead of storing intermediate resource reprocess. It might be a little bit confusing there. I don't know.
Sorry, which part is good? Sorry, which
The
part is
data source references.
Mhm.
Because the field is designed kind of more or less kind of centric around the restoration process. And do you have a similar diagram for restoration? What's the restoration like
restoration of
of the volume?
The CBT won't really play in the restore process.
Yeah. So this volume here is pre-created by the backup software.
Yeah, I understand that, but if I'm a end user, I want to restore volume. What do we do?
Restore a volume from
From volume snapshot deltas.
I'm not exactly
So,
following.
so volume snapshot delta is just the CBT. So it's the changes between two snapshots. So on restore, you wouldn't use it. So you'd restore from a volume snapshot, right? That would be your data source kind.
Yeah. I think the idea, yeah, so yeah.
Sure.
So the idea, sorry, inside the code, right? It's just like, hey, go find this thing, and then find like the volume snapshots, and then like issue the gRPC call. So in a sense, like, yeah, I guess maybe potentially the confusing part is like, this is not like a data source per se, like literally a data source. It's just like a way for the volume populator to say, okay, this PVC, it will contain data from this particular thing, this particular kind. And then like the code is just like, hey, find these two volume snapshots, find the volume snapshot content, issue the gRPC call.
And what this is a backup workflow, right? So backup software does the backup and store all the change blocks in a persistent volume claim that is mounted to the CBD populator, right? What's next? The backup software must be able to ship this thing to somewhere and later on use this thing to restore the volume, right? That's the fundamental goal.
No, not quite. I think the flow is getting a little confused. So the idea was we needed to get the change block delta or change block data, right? And so we're getting pushback on moving it through the API server. So
Sure.
Ivan came up with this idea that we could put the change block data into a PV and then read it from the PV. So this is actually coming. So the data, the CBT data is coming from the CSI provider being, provided to the volume populator, which then writes it into the disk. And it's basically going in there as a file. So we could read the file by attaching it.
Sure. But eventually the backup software does the change block tracking calculation for backup purposes and restore purposes.
Well, so we're using it during backup to say, hey, we only need to back up these blocks. And then we store all the blocks in whatever our backend repository is, right? So at that point, we've got whatever changes we made, but that's kept internal to the backup software.
But how is that exposed to backup software? How is this volume be used by backup software is my question.
It would attach the volume, read the CBT data from inside of it by a PVC mount, attaching it to a pod.
You cannot. The CBD populator is still there.
No, so this is not so the volume, it was never like mounted to the CBT populator.
Then how do you write into that?
So you spin up an ephemeral pod to do it, and after that you just kill the pod, right?
Who spins up the CBD populator?
The populator spin up the pod, write the CBT entries into the volume, then kill this ephemeral pod, and then like that volume would just be, and then like from the backup software perspective, it would just be a static like provision PVC with CBT entries inside.
Okay, and then the volume snapshot delta contains the status whether this volume has been written or not.
Yeah, like this information around like at the end. So the idea is like as this ephemeral pod is writing it, it will just asynchronously update like the state with the status of resource, and eventually it will just say when it's all said and done, it would just say, okay, we're done. How many blocks did I see? The block size that the provider told me was this amount, and how many have I returned to? How many bytes have I returned to this? What's the volume? Sorry.
Got it. So sorry, I missed the last meeting, so was trying to catch up over here. Okay, so the change block populator watches the volume snapshot data resources and the PVC resources. And it knows that I need to take care of if the data source reference is pointing to a volume snapshot delta.
Mhm.
Then once it sees that, it spins up a temporary ephemeral pod,
Mhm.
which mounts this volume.
Mhm.
Yeah, I don't know how that works.
And then they're gonna all be in the same namespace as the volume snapshot that will specify.
Okay, and then the informal pod will also need to watch volume snapshot delta or
No,
get information from there.
no, like the CBT populator would have like okay, I see what you mean there. Like because like the CBT populator like it would or the CBT entries will still be in memory. Somehow like it needs to be able to like find a way to like put those in memory CBT entries to this guy, and this guy can write it to the volume there. I think like the mhm.
It's gonna be again a service, right? So because
Yeah,
eventually the CBD populator is making the RPC, is not the ephemeral pod.
yes, yep. I think like there is like I think like there was the inside the they have a hello world like CB not CB they have a hello world volume populator on how on what they did was like they put it into like um uh an ephemeral file within like the populator, and then like somehow and then like the ephemeral part like is able to read that file inside that is on the CBT populator ephemeral volume. So there is like an intermediate step here in between um to
So let's say, assuming that you have finished it, you have this ephemeral pod, and data got read into this volume, and then does the backup software has to read this volume again?
it will like
Another step?
so it would just be up to the backup software to resume that backup operation, right?
So it's
So
probably like a data mover pod will be attached to this volume, something like that?
yeah.
Oh.
The original, at least like this is where the original thought is like maybe that data mover pod would mount the CBT volume, and then at the same time ideally it should also be able to mount like the volume with the data blocks, right? So this is not taking into consideration like the data token approach that Dave brought up last meeting. So this is just like the current way of how the data mover pod would mount the volume and to get to the actual data blocks.
It would need this volume and the target snapshot, the second snapshot as a volume.
Yes. So at least like that part of the data path, like like hopefully like the backup software would know how to do that, right? So from a CSI perspective, it's kind of that's out of scope.
Yeah, I think it's durable. I was still my concerns the same from last time. Still the added overhead performance thing, right? So it's the creating volume attached takes time. We have to do this every time. Yeah, so that's my concern, I guess.
Yeah, I think that's like definitely a legitimate concern. So since like multiple a few of you have brought this up, I brought it up. I think like so I'm at a point where I feel like it'd be nice to get some like not be nice, but I think it'd be necessary to get some benchmarking to see how bad it is. It's just like again, right? It's just like the networking argument, right? That was presented to us. Oh, it's bad, but nobody knows how bad it is. I feel like it's one approach or the other. Like it's up to us to come up with some numbers to convince ourselves and convince others outside of this working group that it's not that bad. But that's legitimate concern, but it's like how bad it is. It's up to us to come up with actual numbers to convince ourselves and convince others. So like I said, right, like I haven't had a chance to fully like benchmark like the overhead, like the at least like just on our side, like it didn't seem like that big of an overhead. It's something that like we can at least for our like product, like it's something that we can accommodate. So but I can't speak for like other providers. So on our side, like we could do like 50 to 100 easily in a second in parallel.
But provision volume, that's dependent on the storage provider, right? It's not really
Exactly.
Yeah.
So it works for like I would say like it sounds at this level it feels like it works for us. I cannot. That's why I say I cannot say it works for by us. I mean their products, and also like from what some of the internal benchmarking we have with FCD and stuff like that. So and hence like this is we're still in the prototype phase. We're still having discussion about this, how this can serve like community at large, not just like one or two specific providers. So, but so before we go back to the resource overhead, like from a API, from a workflow perspective, is it reasonable? So if then we can if there's something like flawed about like the API or the workflow itself, then we don't even need to argue about like resource contention and overhead, right?
Yeah, I'm afraid we will get blocked by data source reference.
Because of the is it
Because
because of the
the ownership of the field, sorry, the ownership of this PVC in this volume, it's not super clear. Right? This is firstly, it's gonna be owned by the informal part, and then later on it will be used by software, the backup software.
how is what makes why is it a blocker? Like
Because
it's not
go ahead.
it's not uncommon to have like statically pre-provisioned volumes that that maybe we can argue that the owners are not clear until like whoever the workload decided to mount it, right?
Sure, but how I was trying to imagine how backup software can make that orchestration happen. Right. The data source reference, it's basically designed, or I'm not sure what's the current status. Maybe it changed. But in the early days, it is purely designed for serving as external source of populating a volume. And
So
this,
you mean like it actually points to an actual data source, or
yeah, it's actually like data populator. If you look at Ben's like, implementation as of today, it's literally a source of data.
I think he just used like some sort of well like in the example that I saw, it's just like it's just NACRD, right? And then at the end, the implementation is still like it came from like a static file or like a static text string. I feel like that kind of like data source details implementation.
We can check. We can certainly check.
Yeah, I mean I know which example. Yeah, I'm sorry, I know which example you're referring to. But I felt like that kind of data source details is not I guess the whole point of having an API is like the backup software doesn't need to know what is behind that CRD, right? It's like, hey, I just this is from by looking at the from an API perspective. It's just, hey, I have a PVC and it has some data in it, and that data come from this CRD. Or if I want to say if I can just change it to
I'm not
like that.
disagreeing with you on that though. The
Yeah,
folks
I
using this field should be aware of what they're doing. I agree. It's just a matter of conceptual-wise or from my poor understanding wise, it sounds like it is actually populating the data from volume snapshots. Anyway,
yeah.
that's one. The second thing is if you go again, sorry, number 3.
Mhm.
I I I don't quite get how the number 3 happens.
Yeah, so I think the I haven't finished the implementation of this mounting part yet. I think essentially once it gets this
Mhm,
CBD payload, initially
mhm,
it's going to be all in memory, right? So it
mhm,
has to we can potentially have this would have to be some sort of local ephemeral
mhm,
volume that is mounted to the populator,
mhm,
and then this is where it will go, the CBT in memory will get um returned to, and that's
mhm,
kind of like the what the volume populator example did, I think.
mhm.
And then the ephemeral part, we just have to move it from one ephemeral volume to the
Again,
final volume.
how does the ephemeral pod access the local ephemeral volume?
You can mount it, right?
No, you cannot. It's a local ephemeral volume of the change block populator.
Oh, okay. So it cannot do. Okay, right. You cannot mount. Right, it cannot be mounted by 2 workload at the same time.
And you have to make sure the
Hmm.
ephemeral pod scheduled on the change block populator node as well.
Hmm.
Before the operating system, I don't know what ephemeral volume the populator was using. Before the operating system actually recycles it.
Yeah, exactly. Yeah, yeah. I think yeah, that's a very good point. You cannot have 2 volumes, 2 workloads mount, whether regardless of what the ephemeral volume looks like underneath on the node. Um,
Can we
yes.
make this ephemeral pod actually just a REST service?
Then then now we just have to send it. Then we might as well just go back to directly sending the CBT entries back to the backup software, right? If this part here has to be networking, number 3 has to be networking, then we might as well just directly push it back to the backup software. There's no,
Pushing
I
it
don't
back
see the
to
benefit.
back. So there's a difference over here, right? If it's pushing back to the backup software, then we're enforcing backup softwares to implement the same APIs the CBT populator in this diagram can talk to. But having our own service means that we can standardize that push API and we can expose a get API for backup software. So what goes underneath as a storage system, whether it's a persistent volume or I don't know, object storage, whatever it is, it's completely under control of the service.
So you're saying potentially this can be an cozy type of thing if we want, however,
Yeah,
wherever we
whatever it is.
whatever we
Yes.
want to do it.
Yeah.
Um,
It just figuring out all this volume mounting and the change ownership after one part is done and another part take over. This I feel that there will be quite a bit of orchestration needs to happen, and
yeah, and
it
I
can be
agree. Yeah, I
it
think
can be
yeah. Mhm.
it can be very prone to error.
I agree with you. If there's no other way to do number 3 without get another volume, then I personally kind of don't like it because of just now we need to exactly like what you said. There's too much orchestration that needs to happen internally at least. And you can. I mean, one can argue that at least all of this is abstract and from the backup software. Backup software is insulated from all this complexity, but still, I think it's a bit more than I want to maintain, you know, at least from at this stage. So yeah, no, I don't know. Yeah, off the top of my head, I don't know how to do this. I have to without like another volume pin. I don't think it's then by then it's like forget it, you know, like just send it back to the network over the network back to the backup software directly type of things.
Yeah, one of the counter argument I hate to bring this up, but I think this does happen previously when we start talking to this, because this is effectively already kind of on the data path already. So one of the reasons why community does not quite like the REST API idea was that it's not Kubernetes native. So and that's the main reason why I think they want a CRD instead of REST APIs, where CRD itself contains a lot of limitations, which you know the limited amount of storage can we can have in each CRD itself makes it not a very proper structure to hold change block tracking data. Yeah, I don't know, man. If we go back to the rest,
Yeah,
rest.
I know. Like even like so Sukana and I have been discussing this too. You know, like it feel like at the end we might just end up falling back to that initial design from like I don't know 5 months ago, where we just expose like an external REST endpoint. Then you know, then end up like we don't get SIG architecture won't be concerned about it. Then we don't have like volume pre-provisioning overhead, etc. Of course, the you know the trade-offs there, like you said, like is not very um, Kubernetes native, and then we have to also like deal with security. Not the end of the world is doable. We just have to like write code to delegate authorization and authentication to Kubernetes API server. We need to manage TLS cert. You know, but it feels like you know, like we might just end up going back to that at the end. You know, if like volume populated doesn't work and aggregated API server continues to you know, if we're not able to convince the architecture that you know aggregated API server would not be a you know potential bottleneck or like resource thing.
Yeah, how did that piece go, by the way?
Sorry, which one?
The aggregate API front.
I mean, like, so yeah, we've been chatting about this like as well, and I think the main thing was like, I don't know if I have it here. I think the main thing is like, let's see. I think the last a bit slow here. The last feedback we got from Clayton was that like, you know, where is it? Okay, if you can see my GitHub page. I think it's just here, right? Like his thing is like, you know, somehow like the API, the bandwidth requirement did not materially change the P99 bandwidth profile of the API server. What I mean by that, so again, right? He said like, there's also he going to like why this is appropriate for exact log forward, but not appropriate for ours. So if we can prove this, right? Like if we roll this out into like a Kubernetes clusters and test it with some reasonably sized volume and pull like the CBT entries, and then like this, the P99, it doesn't affect the P99 latency of API server, then we at least we have like something that to go back to them and say, hey, it's not as bad. Now tangibly, what does this mean? Not much information here. I reach out and say, hey, you know, just like I'm just trying to like have have a good chat with us in here, have enough conversation here first before I ping him directly. about this to get some clarification. But I know, like, for example, like the API server, I shared on Slack. It has the API, the Kubernetes API server. It has some SLO alert that like would measure and predict like the latencies of the API server.
Yeah.
You know, if it goes beyond like that SLO, like the alert is gonna fire, and then like the API fairness and priority thing is gonna kick in, and API server is just gonna start throttling and start like cutting off rate limit like some of the API calls. I think that
Yeah.
is the main concern here. So I mentioned, right, I also mentioned to you, like, hey, you know, I talk about priority and fairness, or fairness and priority. I can't always remember which comes first. I mentioned it in this cap too. I was like, hey, you know, and I talked to Jeff about it too, and then he said like he liked that we include like you know, we account for fairness and priority. But he also understands like where Clayton is coming from. So I guess it's really up to us to prove that, you know what, if we roll this out as an aggregated API server, you know, API server, the SLO alert is not going to fire.
I'm afraid we will.
Yeah, right, because that thing is not like an average user can configure, right? And it varies from cluster to cluster. And where was it? I found it somewhere. If folks are interested, because I remember having to deal with it when I was working on OpenShift. Just for reference, right here. Yeah, this thing here, right? So this is where it measure like thing, like the burn rate, and then it goes into like some elaborated formula, yeah, computations and calculation. And then when that thing fired, the APF is going to kick in, and then, you know, then the users, like, they will see tons of warnings and errors in their Kubernetes control plane blocks. Yes.
Yeah, it's a hard problem to solve.
Yeah, I guess I remember, if I might be, yeah, I remember being that person who put all this in. Yes, I spent like 2 months dealing with this. It's not fun to deal with. I think this is the main concern here. If we can somehow spin up a cluster and say, like, you know what, oh yeah, this is terminated the request, because API server will terminate your request. Imagine like this kicked in while you're halfway doing your backup operation, and then the Kubernetes API say, oh, I'm gonna start terminating your request even though you're halfway paging through your CVT. It's gonna be a really bad user experience, and there's nothing the user can do to recover from it, because they have to cut the operation and just wait for API server to slowly recover from it.
You probably won't even be able to restore, recover from it if the load is just too big.
Yeah, you have to wait for the API server to recover itself, which is like the, you know, yeah, I spent a couple months with this. So, but anyway, so I think that's the gist of it. Yeah, I am open to like suggestions on, like, shall we continue to try to figure out if volume populator will work? Shall we I mean, okay, so there are multiple, feels like there are multiple fronts that we can attack this, which I think like you know, we can come up with some numbers and say, hey, you know, the P99 is not that bad with an aggregated API server. We can like brush off the dust of the initial proposal and say, hey, we're just going to expose, like going back to the expose out of band REST endpoint, still with, I think, Kubernetes cluster, but it doesn't go to the Kubernetes control plane.
I kind of agree with the Colin on his statement. Typically, you want to avoid data path traffic through the control plane, because data path typically needs to be a little bit more available than the control plane components, right? Like your PV controller may have 99.9 of availability, but your data path of writing data into the volume has to be like 6 nines or 7 nines or whatever it is, 5 nines typically within a cluster. Yeah, going through, allowing the data plane traffic through the control plane itself bottlenecks the availability of the system to the availability of the control plane. So that's one thing. The other thing, the main thing that we're talking about is actually network bandwidth issue. We can do throttling to make sure we don't bleach, but in general, if we could, maybe we should.
Well, I think CBT, I mean, it's kind of halfway in between data and control.
Yeah,
I mean,
it's
depending on which way you look at it, it's, you know, it's control information, right? But there's a reasonable amount of it. That's why it starts to edge towards data.
right. We did some math before, right, Dave and Ivan, for that. I think the really thing is the first one, right? When we first take a snapshot of the big volume, and between the first volume to there's no snapshot previously, then effectively the change block is basically the entire thing, right?
Yes, but we really have to look at things like returning extents. So, you know, we should be returning extents, not, well, we have the bitmap idea, but in general, we should be returning extents, like block X to block Y changed. And so your worst case is every other block was changed. That gives you all the extents are, you know, size 1. And there's every other extent. If the entire disk changes, you know, then you have one extent, 0 to n.
The bitmap idea does not fit into the token, right? The token one.
The bitmap idea, so the bitmap idea, yes, you don't get the tokens back because you reduced it to single bit.
Yeah.
Yeah. So I worry that we're trying to design for the worst case when the worst case is really the one you can probably ignore, because things like every other block on the disk changed, just back the whole thing up. It's really, you know, you're really not gaining that much by skipping half the blocks.
But this is a common though, because the first time you back up is always like that.
No, because we're talking about extents. So for example, like if you changed every block on the disk, right? You get back one extent. It's going to say block 0, block 1 million. And that's all you're going to get back. You're going to get back like 50 bytes of data. Right? If you're extent based and everything on the disk changed.
Sure. But again, this is where we.
So, yeah, I think like
You're talking about ranging, right? The key thing is, okay, maybe the worst case scenario is not that bad. It's basically just half of, right? Just every other block you need to change. You changed.
That's like your absolute worst, I think. And then you've got like this initial backup problem, and it's like, how is the disk written? How big are the blocks? You know, so how many of these extents are you going to get back? And that's, you know, we could mess with that a little bit. There are other things you could do. You could constrain it. You could say, look, you know, if there's more than, you know, 64K extents, just back the whole disk up. It's an optimization, right?
But yes, API, you cannot do that, no?
Sure, we could. We could just say, because we're returning whatever we say. So, like, for example, if there's more than 64K extents, you say, you know what, back the whole disk up. I'm going to give you the extent is 0 to 1 million, you know, the whole disk.
No, I kind of disagree on that. The API needs to have a very clear contract, right?
That is a clear contract. If the API tells you block 0 to block 1 million changed, that's what you got to back up. It's the entire disk.
So that's assuming it knows that block 1 million is the end of the disk, right? Like it
has to know the end. Well, not the backup software. I mean, the backup software needs to know that because it needs to know the size of the disk in order to back it up.
So I think like it feels like I guess like not just the so even if we park like the worst case scenario aside, you know, like even though the worst case scenario is not that bad, I'm just trying to think like even if like we go it's just from the perspective from again, right, just rereading like the comments there in the cap a matter of stability, right? If something like goes bad, assuming like everything goes through the Kubernetes control plane, if something goes bad, best case scenario, average scenario, whatever, something goes bad, what can the user do? There's nothing, because if
Read the whole
everything is
disk.
no. If the control plane is affected, if API server start to terminate requests,
Yeah. Then you didn't get your CBT data, and you have your choice. One
halfway
is
through halfway through that paging process, like
so the CBT data is an optimization. It's not
so
required to do the backup. It's an optimization.
so
So
regardless, right?
well,
If something
regardless, I mean, if for example you get an error on reading the CBT data, you have your choice. You can say fail the backup, or you can say, just back up the whole disk.
So if Kubernetes API server, like the P99, the SL alert starts to fire, it starts to rate limit and throttle, basically the API calls, that affects the control plane. That affects the rest of the cluster. So regardless of whether best case scenario or what we do on the backup software side.
Sure, but that's really depending on how much data is really being pushed through it, right? Because if we're commonly pushing through enough data to break the API server, we shouldn't be doing that.
So enough is subjective, right? Like we there's no like we can't make a blanket statement around like, oh, this is how every server, how much every server.
Now there has to be a blanket statement. I mean, you can say it's 1K, 10K, 1 megabyte, right? I mean, there's got to be a point where the API server handles it or it's broken.
So
I mean, that's kind of like saying you can't put anything through the API server because anything might overload it because you might be running on somebody's wristwatch. I mean, it's like that's, there's always some minimal, reasonable expectation. I mean,
right,
this is
so
not different from anything else, right?
Right, and hence they have the SLO metrics defined. So it's up to us to prove that. Like so it's 5K, 10K, whatever numbers we plug in here is just speculation, right? So then hence like those alerts and matrix that I shared are like concrete data that it's up to us to prove that it doesn't.
Well, so work it the other way. Is there a number that is a max that we should be pushing through?
I think it's just as long as like the API server alert doesn't fire.
That's basically a rock fetch. I mean, there's
You cannot easily control. That's the key thing. This is a shared API server, is shared across the board.
But
So
everything, so this is no different than everything else, right? I mean, why is this different?
it's because its load is too big.
No, you have to define what too big is and then make sure you stay under it.
That's the reason why they're asking you to run stress testing, right?
No, because that doesn't make any sense. Because that's saying that because we can cap things. For example, we could say we will never return more than X megabytes of CBT data.
No. That's size, right? It's also a frequency and the number of the QPSC, right?
Again, I mean, these are all things you can calculate out. I mean, it's the same thing. I mean, if the backup software decides to create volumes from 1,000 snapshots, right? That's simply what it does. It's the same thing if an app creates, 1 million pods. That's what it did. I mean, it's kind of ridiculous.
I think those are all good points here. So I'm just being mindful of time here. Like we have 1 minute left. I think like to quickly sum up, like I think just one last item I want to share. Sorry to interrupt there. I think like so it's about I think like Prasad has agreed to like maybe help us with some of the networking benchmarking there. Maybe like we can talk about it offline about how to put some like concrete numbers to back up our claims at the end of the day. I think like somehow to some extent like we ourselves here are convinced, we have concerns, but we're also convinced to some point that maybe that is the right approach. But we need to convince like the bigger group at large. But one last thing, I know it's 10 o'clock, but I have brought up this a few times, alluded to this a few times. Like we found like currently not being active on the CAP. I don't know when he will be returning to this CAP if he is. I need help with like someone to co-author with the CAP. I believe that Prasad has kindly agreed and to step up to a co-authorship role to help manage the CAP and move things forward in case like I'm on holidays or whatever. So yeah, is that all right? Is that still okay, Prasad?
Yeah, sure.
Okay, cool. Yeah, I'll update the CAP and add you to the co-author list there. So okay, I think like
Thank you.
Yeah,
I think
thanks
we're out of
everybody.
time over here.
Okay, we'll be in touch. Happy New Year. And happy holiday. We'll touch base again in the new year. Thanks everybody.
Thank you.
You.
Thanks, folks.
Bye.
Cheers. Bye.